Okay, this is a Tech Math 3P Calculus Combined class. We're in Chapter 10, and for some reason, we're done with 9. That's what happened to 9. So for some reason, we're done with 9, and we're slowing down. We're only going to do 2 sections today. So that's pathetic, right? We should do 3 anyway. I guess not. So we have things called trig functions. How long have we had trig functions? How long have we had sines and cosines and tangents?
Since they started putting away with calculators.
Well, as a matter, no, further back than that. The Greeks in the 5th century BC had sines, cosines, and tangents. They were doing trig, yes. Now, they didn't have the base 10 arithmetic to help them out, so they're doing it in some weird type of arithmetic. But you figure that, and prior to that, the Babylonians, they were doing trig as well. So it goes back a long time because it has to do with property rights. As soon as I can go and say this piece of land is mine, then I need some geometry to figure it out, and I need some trig to figure out the geometry. So it probably goes back further than that. Now, our friends in Babylon, so Babylon, I misspelled it really bad.
That's not how you spell it.
Y-O-N? Okay.
No, baby.
It's baby one.
Okay, there we go, Babylon.
Wait to do it.
They were doing base 60 math prior to sacking Jerusalem and taking the Jewish guys into captivity. Their math system for 500 years before that was base 60. So that means they had single digits from 1 to 60. They didn't have a 0 yet. But that's why we have 60 seconds in a minute and 60 minutes in an hour, because that's what the Babylonians had done. So a totally amazing feat. Now, they didn't train everybody in math. The general population didn't know that, right? It was only the elite that knew that. Yeah. And during the Middle Ages, so between 600 or so AD and Newton, the time of Newton, 1604 or something.
The one with the apple, right?
Yeah, the guy that with the apple.
The one that dropped it, now they eat it.
Who had better math?
Hmm?
Who had better math? The Chinese,
That's about blood.
the Japanese,
Let's say the Mexicans.
the Mexicans. We wanted Mexicans, if I can spell Mexican.
Rich, and I don't know why.
No, Mexicans. There's an N in Mexicans. The Mexicans, the Indians from India.
Oh, those guys are good.
So the Indians or Western Europeans.
No, they lost. Look at the Soviets. They're
Yeah,
ready
so-
for
So what do you think? Well, it wasn't these guys, that's for sure.
it. Yeah, definitely
And it wasn't those guys. Well, these guys probably came in a close 4th. But these guys here were right up there on top, doing all kinds of really cool math that is unbelievable. And in 600, well, let's look at 1100 AD. So 1100 AD, that means 1,000 years after Christ. We're all disappointed. He didn't return after 1,000 years. We're getting ready, right? And Christ didn't return.
And then you get the
100 years after that, you have universities, things at universities in Europe. How many books did they have in their library? On average?
Oodles.
10. At the same time in Baghdad, there was a street a mile long that had booksellers that had over 10,000 different titles to be sold. And the European libraries only had, the normal university at the time had 10 books. Just one of those things. Okay, well, back to sines and cosines.
Who was it?
What we're going to do,
Indians.
there are,
Japanese.
Who was the best?
the best would have been China, followed by India, then Japan. Yeah,
Wow. Knew it.
yeah.
You did.
But it wasn't the Western Europeans. We were way far behind. Now, we covered that Columbus sailed the ocean blue in 1492, right?
Mm-hmm.
We already covered that. What happened 50 years before that happened? So 50 years before Columbus sailed the ocean blue, something happened. All right. Okay, we'll give you a hint. It happened in China.
Ooh.
Yeah, it happened in China. All right, so in China, 50 years before Columbus, the Chinese, there was a Chinese admiral in China at the time. He had 1,000-ship navy. And these were not little things. These were all ocean-going things. And he was set to take that 1,000-ship navy and conquer the entire world.
Ooh. Yeah,
That's what he was doing. Yeah, that was his plan. Luckily, China has an emperor. The emperor changed. The new emperor said, "That's a waste of money. We already have the whole world right here in China." They burned their 1,000 ships. 50 years before Columbus sailed the ocean blue. If they would have just set sail, they would have taken with them a big enough army. They already had gunpowder. They would have easily taken over the whole world. And we'd be talking Chinese right now.
We're eating Chinese food all the time.
Now, what the Chinese do in 4 BC? Anybody know what happened in 4 BC in China? Other than they're watching for the stars to something happen in Jerusalem. What? Well, considering that we're talking about burning your 1,000 ships, something like inventing paper wouldn't even be close to how bad it was that they did. Yeah. Anyway, in 4 BC, the Emperor of China, a brand new guy again, takes over, and he issues a decree. The decree is, bury all scholars, burn all books.
Oh, I have heard about it.
Yes. So here's a society far more advanced than Western Europe, and we're going to bury all the scholars, and we're going to burn all the books. I mean, again, there was an opportunity there for China to be on the moon before Columbus sailed the ocean blue, and they blew it twice. And so the moral of the story is, when you're getting a form of government set up, make sure your leader's not a god.
A guy?
A god, G-O-D. Yeah, don't make sure that you don't declare your leader a god, because when you do that, silly things will happen.
He gets crucified.
Yeah, and no, what he says, you know. So, in the Navy, the captain couldn't walk around the ship saying, "This is dirty, that's dirty, the other thing's dirty." You can't do that, because if he did, the whole crew would be up cleaning the ship. Okay? Because, your wish is my command type thing. And so that's what happened. Anyway, back to here. What we're going to do is we're going to take an XY coordinate system. X, Y. Well, it'd be too hard to get a real XY coordinate system. And we're going to have some point in it, and we're going to call it XY. Oh, that's cool. So that's XY. And it could be anywhere in here. It could be over there someplace or down there someplace. And then we're going to say there's a distance from the origin to that point. We're going to call that R. And that's going to be the square root of x squared plus y squared. Also known sort of like the Pythagorean theorem, a squared plus b squared is c squared, right?
Yeah.
Yeah, same type of thing. Except we're going to call it R is the square root of x squared plus y squared. Now, once we've done that, then we're going to define all of our trig functions. And we're going to say the sine of some angle. Oh, we got to need an angle theta. So I have some angle theta sitting there. And we're going to say the sine of the angle theta is the y over the r. And we're going to say the cosine of the angle theta is the x over the r. And then we're going to say the tangent of that angle theta is going to be y over x. And then we're going to have a cosecant of that angle theta, which is going to be 1 over the sine, which is going to be r over y. And then we're going to have a secant of that angle theta, 1 over the cosine, which is going to be r over x. And then we're going to have a cotangent, which is going to be 1 over the tangent, and that's going to be x over y. And in the case of r can't be 0 unless x and y are both 0, and that'd make it rather trivial, right? But in the case of the tangent, x could be 0, and cosecant y could be 0, x could be 0, y could be 0. So the functions tangent, cosecant, secant, and cotangent could have places where they're undefined, go to infinity, because I'm dividing by 0. So that could happen to me. And I guess that's all there is in that particular chapter. Well, I guess not. I guess there's a little more. Not much. All right, so if I have I'm back, I got an xy coordinate system. Okay, and I have the first quadrant, and I've got a second quadrant, and I have a third quadrant, and I have a fourth quadrant. So I go around. Now, why did they do that going in counterclockwise? I have no idea. You know, that wasn't, Descartes did not do that, because Descartes' coordinate system did not have a right angle. Descartes' coordinate system was something like that, x and y. It wasn't until Newton came around and put a right angle there that we ended up with a right angle thingy. Anyway, so that's the way we number it. And then we say, well, in the first quadrant, the sine is going to be positive. The cosine is going to be positive. The tangent is going to be positive. So if I have an answer in the first quadrant and I'm asking what the sine is, and your calculator gives you a negative number, there's something wrong with your calculator. I look in the second quadrant. I see that the sine is going to be positive. The cosine is going to be negative. The tangent is going to be negative. I look in the third quadrant. Sine is negative. Cosine is negative. Tangent is positive, because I have a negative x, negative y, the tangent's going to be positive. Fourth quadrant. The sine is negative. The cosine's positive. The tangent is negative. So, all right, so I have that. That's something I got. And then look at one more thing before we start working problems. So I've got a sine, a cosine, tangent, cotangent, secant, cosecant. Theta, 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 theta. And I ask myself, what happens at 0? 0 degrees. Fine. Sine is 0. The cosine is 1. The tangent is 0. The cotangent's undefined. The secant is 1. The cosecant is undefined. Cosecant's 1 over sine. I got a 0 there, so that's what would happen. I look at 90 degrees. Sine is 1. Cosine is 0. Tangent is undefined. Cotangent is 0. Secant is undefined. Cosecant is 1. I look at 180 degrees. I look at 270 degrees. I look at 360 degrees. So I have to fill that in?
Yes.
Oh, bummer. 0, minus 1. Minus 1, 0. 0, 1. This is going to be the same as that is over there, so I just do that. 0, infinity, 1, infinity. So I got those guys. All right, come down this way. The tangent is going to be 0. The tangent is going to be undefined. Cotangent is undefined. Cotangent is 0. Secant minus 1. Undefined. Undefined minus 1. And maybe we should have plus and minus undefineds. No, we're not going to. We'll just leave it that way. Now this causes a problem because my sine function's doing something like that forever and ever and ever, and the other way too. And we'll get around that at a different time. But, so that's what my science function does. Okay, well, let's solve some problems and see if there can't possibly be any real problems in section 1, right? So we should just skip it? Is that what we should do? No? Okay. Problem number 2. Draw a graph of the angle in standard position. All right, standard position means that this is 0, this is 90, this is 180, this is 270, this is the x and this is the y. And if I'm minus 60, then it's that way, minus 60 degrees. Oh, that looks like more like minus 65, doesn't it? I should redraw it. No? All right, that's fine. All right. We're going to look at number 4. Why don't we go and see if I can find some graph paper. Gallery Essentials, Mathematics, Statistics, Graphing. No. Dice. Deck of cards. What they do? Wait a minute. Interactive pictures. There we go.
On top. Right there.
I want that one.
Axis.
I thought. Okay, I'll use that one. I don't want to use that one. I'd rather use something else, but I guess I'll use that one. All right, so back to here. We're going to copy it so that way I can paste it if I need it again. All right, so here we go. 1, 2, 3, 4, 5. Yes, 1, 2, 3, 4, 5. 1, 2, 3, 4, minus 5. 1, 2, 3, 4, minus 5. All right, so now we're looking at standard position. What are we going to do? Number 4. Number 4. And we want 390 degrees. All right, so if I go around once, that's 360. So that means I have to go 30 more. Okay, so if I go 30 more, if I go 1, 2, 3, 4, 5, 6, 1, 2, 3, then that ought to be 30 degrees, right? A way to go. Missed the dot. Oh, much better. 30 degrees. Number 4. Oh, 390. 390 degrees. I come all the way around, all the way back. Oh, way to go. I went through the 390. Now you can't see it. Number 8. Find... Where?
30.
This is a 30, yeah. You want me to make it look more like 30? Is that better? Alright, so number 8. Find the smallest positive and largest negative coterminal angle in standard position for each of these angles. Okay, well, it was in English, right? The question was in English. So that means the Mexican speakers in the room, because you guys don't have to pay attention, right? Because it was in English. Yeah. Control V and see if it works. There we go. So coterminal. Does that mean somebody just shot it or something? Terminal. Coterminal. All right, so if I have this guy that way, then coterminal means I start in the same spot. Okay.
What number is this one?
I don't know. Number 8. All right, so I got this guy that's 175 degrees. All right, so that's the way to go. Oh, I know. I can use a straight edge. Where's my straight edges? Right there. There we go. So I can just go and do that. Yeah, that looks like. All right, so there's
Sweet.
175 degrees. Okay, so I want the largest negative coterminal angle. Okay, so if I go this way, like that, then I'm going to have minus 185, and that would be the smallest negative guy. Smallest negative guy. Okay, because the next guy would have to go around again another 360, and that'd be 445, and that wouldn't work. All right, so now I want the largest, what do I want? The smallest positive. Oh no, that's the largest negative. L-A-R-G. Largest.
This is the largest.
L-A-R-G-E-S-T. So the largest negative, because anything with a more absolute value would be smaller in the negative direction. So now I want the smallest positive angle. Okay, so I'm coming this way, I'm going to there, 175 degrees. That's the smallest positive. So the smallest positive, 175. The largest negative, minus 185. And who's going to ask such a stupid question on a test anyway? I don't know. Maybe the author might. All right. We're going to do 16 next. Control V. And number 16. Draw a graph for the angle in standard position, and I want to be at 4 minus 2. All right. 1, 2, 3, 4. There's 4. Minus 1, minus 2. So I'm right there. I take my line drawing capability. Where's my line drawing capability? There we go. I'm going to go start there and go there. Oh, yes. Number 16 is done. 22. Finally, we get to something worthy of the class, number 22. All right, so I'm at minus 4, minus 3. Minus 4, minus 3. And I want to know the sine, the cosine, the tangent, the cosecant, the secant, and the cotangent of that angle. So theta is described as being that point, so I want all those things. Okay, first thing I'm going to do is figure out what r is, and r is 5. Why is r 5? Because in geometry, you had 3, 4, 5 triangles, right? So if 2 of the sides are 3 and 4, the other side has to be 5, right? You also have 5, 12, 13 triangles. If the sides are 5 and 12, you have to be 13. 90% of the trig questions asked on SAT and ACT exams use 3, 4, 5 and 5, 12, 13 triangles. That's why they're there, so you can do them in your head. Okay, so but in the big picture, if I take the square root of 3 squared plus 4 squared, 9 plus 16 is 25. This is going to be 5, right? So that's what's 3, 4, 5. And if I take 5 squared plus 12 squared, I'm going to get 13 squared. That's why it's 5, 12, 13. But if you probably never took an ACT or an SAT in your life. But if you would have seen 3, 4, 5, and 5, 12, 13 triangles on the test, because math majors love them. But that's just, math majors are weird anyway. Okay, so the sine is going to be the y guy over r. The cosine is the x guy over r. The tangent guy is the y guy over the x guy. The cosecant is the r over the y. The secant guy is the r over the x. And the cotangent guy is the x over the y. Are my answers correct? No, they're not. I'll write them correctly. Where? No, sine is y. Yeah, sine is y over r. Well, you got a different book? So we'd call it minus 3 over 5. We'd call it minus 4 over 5. We'd call it 3 over 4. We'd call it minus 5 over 3. We'd call it 5 over 4. What happened? There's a minus sign here, right? So it'd be minus 5 over 4. And we call that 4 over 3. So after we put the r's and the x's in, we would then write it slightly different so that it is more aesthetically pleasing. Okay. So if you don't do that, minus 0, you're not going to take anything off. But your 9th grade algebra teacher would not like you writing minus 3 over 5. She'd rather have you write minus 3 over 5, right? Yeah. So not minus 3 over 5. It's minus 3 over 5. Right. Is there a difference? No, there's no difference. It's just you know that type of teacher. Anyway, we will do 32 next, maybe. Well, maybe not. Yeah, we'll do 34 next. Number 34. Use the defining ratios show each are equal. Let's see, tangent theta, I'm supposed to show that that's the same as 1 over cotangent theta. Okay, so tangent is y over x, and cotangent would be x over y. I should have just said check, right, but they want me to do this, so that's what I'm going to do. All right, so I'm going to go and multiply top and bottom by y over x. Y over x. The y's go away, the x's go away, and I got y over x, and I have 1 times here, and I have times 1 there. And, oh, yeah, y over x is x over y. It checks. You know, sometimes we have to strain to have a problem, right? And we're going to define tangent as 1 over cotangent. Now show that it's right. Yeah. Only you had to. Anyway, we won't mention what type of people they are. All right, now we're going to go to 10.3. 10.2? 10.2? We're going to go to section 10.2, and we're going to talk about reference angles. Reference angles. So my reference angle is always a first quadrant answer. Okay, so if I look at the sine function, I go up, I go down, I go up, I go down. and I look at something like 1/2. So in the first quadrant, I have an answer right there, and in the second quadrant, I have an answer right there. But we want to have be a reference angle, the first quadrant one, so we want to have that answer. Okay. Well, that looks clear as mud. Okay, so I got this XY plane, and I got this point over here. And I got some angle right there. See that angle? Theta. Okay. And the issue is, if I were to take this guy and say he's really over there, like that, he's really over here, and I got this angle theta reference, because see the sine of this angle theta is going to be the same as that angle theta reference. It's going to be the same number. Then how can I describe that second quadrant angle, or the third quadrant angle, or the fourth quadrant angle? Okay, so that's the issue. All right, so I say, well, I have some first quadrant guy, theta reference. In the second quadrant, the theta that I have is going to be 180 minus the theta reference. In the third quadrant, the theta I have that's a third quadrant answer is 180 plus the theta reference. And in the fourth quadrant, the answer to the fourth quadrant is going to be 360 minus theta reference. Okay. So now I'm constantly going back and calculating the reference angle in my physics class. When I'm doing electronic circuits, I probably want to know it too. And those are things I'm going to have to do and figure out. Because see, when I take the sine of 30, what do I get? Put it in your calculator, you get 1/2. When I take the sine of 150 and I put it in my calculator, what do I get? Okay, so I'm going to take my calculator, sine. Oh, also 1/2. Okay. So now if I know if I know the sine of theta is 1/2, what's theta?
30.
Why isn't it 150? Huh? Could be either one. Could be 150 or 30. They're both true. I look at this guy and he's going up, he's going down. There's 1/2. That happens at 30. That happens at 150. So what we end up doing is we're saying I have a reference angle. The reference angle is 30, and now I'm not confused. It might be something, it might be the 150 guy, but I have a reference angle, first quadrant answer, 30 degrees. Okay, and then I go and take my calculator, and if I take my calculator, what's the definition of a function? Okay, so if I have a function, that means that for any x, I get a y. And I only get one y. Right? So if I look at this guy here, is that a function? No, that's not a function, because at some x, there's an x, I have 3 y's. This is not a function. Okay, so now I ask myself, sine, here's my sine guy here, is sine a function? Well, for any place I draw an x, I only get one y. So sine is a function. Okay, so now we're going to do it again, and we're going to look at this guy, and this is arcsine. For every x I pick, I get an infinite number of answers. So it turns out the inverse sine function, if we didn't do something about it, would not be a function. Can my calculator calculate something that's not a function? No, that wouldn't work. So what we do is we define the arc sine guy. We say that we're only looking at him between minus 90 and plus 90. And between minus 90 and plus 90, there's only going to be one answer. Now the arc sine function is a function because I define it on some interval in which it is a function. I do the same thing for cosine, same thing for tangent, same thing for secant, same thing for cosecant, same thing for cotangent. I end up making it a function. But it may not be. So something like that wouldn't be a function. Looks like we have the same exact thing on page 556. I don't see anything different there. But then, well, I guess that's good enough. No, we have to do arc sines. So our calculator has a second function key. So cosine is the first function. The second function key gives us the inverse cosine. Let's put 1.5 in and see what the inverse cosine of 1.5 is. What does it say? Second function, inverse cosine, stupid thing. Huh? Domain error? Heck's that. I get the same answer, domain error. All right, so my cosine function starts at 1, goes down to minus 1, goes back and forth and back and forth. So I just put in my calculator, I wanted the arc cosine of 1.5. Where does that cross that curve anywhere? It doesn't. So you can't take the arc cosine of any number unless it's between plus and minus 1. Outside of that, you end up domain error. There's nothing there. I can't take the arc cosine of 3,572. That would not make any sense. But I can take the cosine of 3,572. I can do that.
So you have to reinforce
Cosine 3572. Boom. And I end up with a 0.882. 0.883. I wonder if I'm in degrees or radians. Anybody know? Yeah, I'm in degrees. Okay. Oh yeah, you better know whether your calculator is in radians or degrees. Yeah, because obviously if my calculator was in radians, I'd get a different answer, wouldn't I?
What should we be in?
Whatever is required for the problem you're working on. So the question for the tape was, well, should I keep my calculators in degrees or radians? Well, in chapter 10, I think we better stay in degrees. Unless we cover radians in chapter 10, then we better be in radians. Yeah. Have days like that, right? So, but you can bet whatever it's supposed to be in, you're in the other one when it's time. Okay? So, be sure to check. All right. So now I'm looking at problem number 2. Number 2. And I have 312 degrees, and I want to find the reference angle. Okay, so I look at that and I say 312, that's a fourth quadrant guy. I remember that in the fourth quadrant the angle's equal to the reference angle minus 360. No, it's not. Anyway, as I was saying, is 360 minus the reference angle. All right, that's better. Okay, so I got 312 is equal to 360 minus reference angle. I have the reference angle is equal to 360 minus 312. Did somebody say 48?
Yes.
All right, so the reference angle is 48. So if I take the sine, if I take the cosine, if I take the cosine of 48 and I take the cosine of 312, I best get the same number. 48 cosine 48 minus cosine 312. It best be 0. 0. It's not 0. Why is it not 0? I fat fingered a key. Cosine 48 minus cosine 312. Well, 0. Yeah. Okay, because both the cosine's positive in the first and the fourth quadrant. So the reference angle and the angle itself, and when I take the cosine out of it, will both be the same. They are. Number 8. I want minus 274.8. I recognize that as a first quadrant guy. Yeah, that's going to be a first quadrant guy because I'm going to go, there's 270. I'm going to be a little bit more. So that's a first quadrant guy. So I'm just going to add 360 to that. And what do I get? 0.2. 4 from that is 6. And 7 from 5 is 8. So that'll be my reference angle. So 374.8 is already in the first quadrant. I just want to turn it into a positive angle so I can figure out what the reference angle is. All right. Number 16. We've got the tangent of 98.3, and we want it to 4 significant digits. All right, so I get my tangent button, 98.3, close parentheses, minus 6.85475, 4 significant digits, 1, 2, 3, 4. Okay, so final answer, minus 6.855. And I know that this is a second quadrant guy. I know in the second quadrant tangent's negative. I'm negative there. What I don't know yet is that the tangent function looks sort of like this. And that transition through infinity on plus and minus sign happens at 90 degrees. I don't know that yet because we haven't graphed a tangent, but when we do, that'll be the case. So that's why we're negative and quite a bit negative. Okay, I agree completely and totally. Number 24. We want the secant of minus 105.0 degrees. All right, now look on your calculator. Where is the secant key?
Right here.
Bummer. Oh yeah, the TI Expire or whatever it is that Ramundo probably has such a key. We don't have one, but secant is 1 over cosine. So 1 over the cosine of minus 105.0 degrees. So we're going to put on our calculator 1 divided by cosine minus 105, close parentheses, equal, and we're going to write down an answer. 1 divided by cosine minus 105, boom, minus 3.864, minus 3.864 because we want it to 4 significant digits. So that's what we're going to do. All right, 26. Now we're going to get sneaky. So far, you've fallen asleep. It doesn't matter, right? Do it in your sleep. The cosine of theta is 0.1849. We want to find theta. Now, this n, we want it between 0 and 360 degrees. Okay, so I'm going to do a graph of cosine. It looks like that. And then I'm going to ask myself, where is 1.8, whatever, it's there. So I'm going to have a first quadrant answer, and I'm going to have a fourth quadrant answer. I'm going to have 2 answers to this problem. So I'm going to go and take my calculator and go arc cosine 0.1849, and I get 79 nearest tenth, 3 degrees, and that's the first quadrant answer. And then I say, well, what is the fourth quadrant answer? The fourth quadrant answer is going to be 360 minus the reference angle, 79.34. Okay, so I got that guy, so I'm going to go 360 minus the answer, and I'm going to have 280.7. 280.7. And then I'm going to say, okay, theta equals solution set, 79.3, 280.7. And then I'm going to just put it back in my calculator and see if it's true. So I'm going to go cosine of my answer, and I get 0.1849. Yep, that's 0.1849. And I go cosine of 79.4, 79.3, boom, and I get 0.1866. So that doesn't help anybody. But it was close enough because I rounded off. Nearest tenth. Okay, good. I got the nearest tenth, both cases. But I have to go looking for both answers if I'm looking at an interval 0 to 360. And we'll have a problem later on where we'll have as many as 8 answers. Yeah, why not? You know, not today, but sometime in the future we'll have that. All right, well, I'm looking at the other page. We'll do 38. 38. I have the cotangent of theta is minus 0.1365. Okay, and again, I'm looking for all the answers between 0 and 360 degrees. So I'm going to take 1 over the tangent of minus 0.1365, and I'm going to come up with what theta is. Oh, I'm confused. Let's start over. Okay, so I have this, right? All right, so the first thing I'm going to do is find the tangent of theta. Okay, so the tangent of theta is 1 over cotangent, which is 1 over minus 0.1365. So that's the first thing I'm going to find. 1 divided by 0.1365, and I remember to put a negative sign on it. So it's going to be minus 7.326. And then I went and took 1 divided by 1 divided by 0.1365 gives me that answer. Because there's a negative sign here I'm bringing with me. All right, now I'm going to take the arc tangent of minus 7.326. All right, so arc tangent minus 7.326 okay, so I've got minus 0.128 degrees.
What are you giving me?
Well, that's what my calculator is telling me.
I got 1.43.
Oh, probably because I took the tangent instead of the arc tangent. Yeah. So with my glorious trifocals, I put in the wrong answer. Minus 7.32 and then boom. So you want 82.2 degrees? Is that better? I just testing you out there to see if you're paying any attention. Minus 82.2 degrees.
Final answer.
No, not final answer. All right, so now the issue is between 0 and 360, how many answers am I going to have? Well, the tangent function does this. That's 90. That's 180. That's 270. Okay, so minus 82.2 degrees so in minus 7.326 is right there. I have two answers. How come it says 82? It shouldn't say 80. Oh, minus. That's minus 82. That's really this answer over here. 3, 2, 2 what? $360 minus 82.2. So this guy here is 277.8 degrees. All right, so that's this guy. Now I got to find that guy. I got to find one more answer. Okay. Okay. So what I'm going to do is I'm going to find the reference angle. The reference angle, and that's going to be 360 minus 277.8. 82.2. So my reference angle is 82.2, and then I'm going to say this answer over here is a second quadrant answer. So in the second quadrant, my second quadrant answer is equal to 180 minus the reference angle. So my second quadrant answer, 180 minus 82.2, which would be 97.8. Okay, so now I'm ready for final answer. Final answer. Theta is equal to 97.8 and 277.8. 277.8 degrees. All right, so I have to be smarter than my calculator, smarter than the piece of paper or the pen that I'm using to do something like that. Okay, we'll do number 42 next. We look and notice that 10.3 has to do with radians. So that means you can't leave your calculator in degrees for all of chapter 10. Okay, so we're going to do 42, and then we're going to go home. we have the tangent of theta 2.3670. Okay, so we're going to go theta equals the arctangent of 2.37267, whatever it is, 67.1 degrees. Okay, so that's my first quadrant answer. I have a second answer. Where is it? Okay, so this guy looks like that. I already have that answer. And it looks like this. I got another answer over there. That's 180 degrees. So this is a third quadrant answer I'm looking for. This is not only my answer, but it's also the reference angle because it's a first quadrant answer. The angle in the third quadrant is going to be 180 plus the reference angle. 180 plus 67.1, 147.1. Okay, so theta equals my final answer, 67.1, 147.1. Because I don't have any confidence at all in my ability to do this, I will take the tangent of 67.1, and what do I get? I get 2.367, and I take the tangent of 147.1, and I get the same. I don't get the same answer. Why don't I get the same answer?
I think is it 247?
It is 247.
Oh, it's 247. That would make a slight difference, wouldn't it? Good thing I checked it. Yes, now they're the same. 247. I put up a second quadrant answer looking for a third quadrant one. That should have keyed me that I was not where I was supposed to be. Okay, so what's happening on Friday? We have a quiz, okay. When's the next test? The 13th, Friday the 13th. Will there be a quiz on Friday the 13th? No quiz on Friday the 13th. Okay. All right. On a day of a chapter test, do we stay until 2:25? No, we do the chapter test and leave. Right, exactly. Boring.
Or overtime.
Well,